Hey everyone, myself Cses and welcome to my channel Codisk. Let's start the problem maximum subarray sum. So here we will be given with n integers and our task is to find the maximum sum of values in a contiguous non-empty subarray. Maximum sum of values in a array that has to be contiguous. Contiguous means one after the other. So if I say this is a contiguous location and it may contain maximum sum of values. Who knows? So here is an example. Here we have positive and negative integers, and of course negative integers would be there because that is gonna pull down our sum. So that's why we need to find what maximum sum we can create, or the maximum sum subarray we can create. So here we found that this is our maximum subarray sum, which is 9. And if you try to find any other solution, that would be less than 9. So that is our answer. So this is a subarray, this is subarray, and they are one after the other, that is contiguous, and that is maximum value 9. If you try to find or use a brute force for this, then it is gonna take to the not linear time complexity, and we want to solve this in linear time complexity. That is why we have this Kadane's algorithm, which is used to solve this maximum subarray sum problem in a linear time complexity. So let's see this. Okay, so Kadane's algorithm basically scans our array from left to right and does two things. First is it's gonna keep track of our sum till here. That means it is gonna, let's say, keep tracking the sum at some position j, and then it will have a memory mechanism, that is like a memory, which is nothing but a maximum sum we have found it in our array. So let's say this is a maximum sum, and this sum till here is gonna keep adding the numbers and will tell whether that number is going up or down. Meaning, let's say sum till here is our x, sum till here is x. Then if I add some other number as the next number, or I should add the next number, let's call that value as I. If I add that number, whether it is going to go up or down. If it goes down, then at this point it goes down. If I move another number, so I have added this. Now I have added this. Let's call that j. No, not j, k. K. If I add this k, this whole increases our sum, and the maximum sum, which was earlier, let's call it y. Now you see here the comparison. As sum till here was x, I added y, it went down, and at this point what I will say, the maximum sum contiguous sum is y, right? Because adding this, it is pulling down. So maximum sum is y. But as soon as I move forward, I found k, and it heavenly pushed up the number, our whole sum, and let's call it z. So now our maximum sum would be not y but z, right? Because sum till here exceed our memory. So that is what these two variables are performing. Memory is just keep remembering the maximum sum, and sum till here is like our warrior. It is going through the arrays of list, and it doesn't know whether it is going up or down. If it goes down, then maximum sum is happy. It is sitting like king there. And in another scenario, so this, I think it is understood what sum till here is doing. It is like a warrior heading towards the arrays, heading towards the list, or heading to the numbers in the list, and it is checking. Now in another scenario, let's use the red pen. Here as the sum was x. Here if I added this number, let's say I, but this time I is pulling down the number as small as 0. It is bringing the number to 0. Then what this is doing? It is like, or not 0, it is making it less than 0, not 0 also, it is making less than 0. Then that means if you add this, this is gonna pull our number to 0. So I will set sum till here to 0, sum till here 0, and the maximum sum would remain y. So that in that scenario, it tells that we are not gonna take this sum, this whole sum. We will start afresh from here, and no worries, I have a memory as y saved of this subarray, which is the largest. So I hope it is clear. Again, let me just do a quick so sum till here was x, so this was our x, and it is like working, this variable is working as a warrior. It doesn't know what next value it is gonna do with our sum till here. If this is I and this is k, so if x plus I brings the number, no worries, that it is pulling down our number. So we have a mechanism of memory, which is this, let's call it y, and if I add x plus I plus k, it pulls the number, then that is great. The sum of this will be our whole, and that is, if x plus I plus k is greater than y, then only we gonna make our memory as x plus I plus k. Okay, so this is was Kadane's algorithm. If you have a still problem in grasping, let's study through an example. Okay, so here we have as an example this array, and we will have two variables, sum till here initialized to 0, and we will have a memory. So memory, we can call it as maximum sum. It is also initialized with 0. Now we will start. We will be standing here and looking. Okay, so this is -2. The number at some index, let's I, it is bringing down our sum till here to less than 0. That means the sum till here remains 0. We are not gonna put this because it is bringing down to less than 0. So we will move forward. Now at this we found 1, so sum till here will become 1, and we see the sum till here is greater than maximum sum or the memory. So what we're gonna do, we're gonna make our memory or maximum sum this only. This maximum sum and memory both are same variable, don't get confused with that. So maximum sum or memory will become sum till here, So since sum till here is 1, it is greater than maximum sum, which is 0. So this will become 1, and we will move forward. We found -3, so sum till here becomes -2, and this is wrong. This number is bringing down our sum to less than 0. So we will reinitialize sum till here to 0, and the sum till here is 0, and this maximum sum is 1. So we're gonna, since sum till here is 0 and this is maximum sum is greater, so we're not gonna change our maximum sum. So at this point of time, what we conclude is, if you look at this, then the subarray is only this. It can be of only one. Subarray can be also 1. So this is only our number, and if you include any then it is gonna pull down our sum. So the maximum sum is till here is 1. Okay, so we will move forward. So we will be standing here now. Sum till here will be 0 plus 4, this is 4, it is not pulling our number to 0, and sum till here is 4, it is greater than maximum sum, which is 1. So we will make our maximum sum now 4. Okay, we'll move forward. This is minus 1, 4 minus 1 would be 3, and this is not pulling out our number, and sum till here is 3 and maximum sum is 4, it is greater, so we are not gonna touch the maximum sum. We'll move forward. This is 2 now, so 3 plus 2 is 5. So sum till here is 5 and maximum sum is 4, it is greater, sum till here is greater, so we will include this, we will change this maximum sum to 5 and we'll move forward. So now this will be 1, 5 plus 1 is 6. You see here, sum till here is such a great warrior. It is making our maximum sum increase. So now sum till here is 6 and maximum sum is 5. So but sum till here is greater, it is 6. So maximum sum will become 6. So now we'll move forward and we encounter minus 5. So 6 minus 5 is 1. I feel pity over sum till here. See how it decreased so much, our warrior. Okay, so this has decreased and sum till here is now 1 and maximum sum is 6. So we not gonna touch this maximum sum again. So you see here, if I look at this, sum till here was keep tracking, it was fighting with the numbers, and maximum sum we found it was this, and as soon as we included the sum till here goes on decreasing, but still we'll move forward now. So will be here now 4, so 1 plus 4 will be 5 and 5 and maximum sum is 6. So maximum sum is, so we are not gonna change it because our maximum sum is 6. So our answer is 6. Okay, so let's see another example. Okay, so in this example, sum till here is, in the starting it is 0 and our memory or maximum sum is 0. So we'll stand here and sum till here, this index, this number at some position, the value is bringing down our sum to less than 0. So we will make our sum till here as 0 only and we'll move forward. We found sum till here as, and now we will sum till here, we will add this, so this becomes 3 and we can clearly see sum till here is greater than maximum sum. So our maximum sum will become sum till here. So this will become our 3. This will become maximum sum will become 3. Now sum till here will, as a warrior, will move forward and it found minus 2. This becomes 1 and maximum sum is greater than sum till here. We are not gonna touch the maximum sum. We will again move forward and yes, it got is sent back and this becomes 1 plus 5, it becomes 6. So this maximum sum is less than sum till here, so this maximum sum is gonna snatch this sum till here and this will become 6 and sum till here will move forward. It found 3, it becomes 9. So maximum sum, it is less, so it is gonna snatch the sum till here, it becomes 9 and this will move forward. This becomes minus 5, so 9 minus 5 is 4. So maximum sum is not gonna touch it. So you see, at this we found maximum sum to be 9 and sum till here is moving forward. So it comes here. So 4 plus 2 is 6. So maximum sum is not gonna touch it. It will move forward. It again finds 2. So 6 plus 2 is 8 it is maximum sum is still greater, so it is not going to snatch sum till here, and we reach the end of the array. So our answer is stored in the maximum sum, which is this. Nice, right? I hope it is clear, the Kadane algorithm. Now let's do the programming of this. Okay, so let's code this. We have n as the length, and then we have the list of numbers. So we will have n 0. This is the size of the array, and then it has to be. Then let's have a vector. Let's make it long, and since there are no further inputs in the problem, so we can use direct while loop. Scene input, and then array dot push back the input. Alright, so now we will display the Kadane. We will pass the array. So let's make this Kadane function over here there on the top. So we will have the return type of function as ll, because who knows, the sum may increase, and it is going to accept the vector, and let's call it ar. So as told, we will have a sum till here variable. That's our warrior. This is our warrior. Now we will have a memory. This is our memory. It's initialized to 0, and this is our maximum sum. Okay, we will scan the array. If you remember the Kadane algorithm, we are going to scan from left to right. So let's make a while loop to do this, or not while for loop, and it has to go. We can also pass n on this, and this is our int n. Okay, and then this will be I++. Now what we need to do, we will have the sum till here variable, and we're gonna add the number because this is our warrior. And also we need to do two things. If, as told, if sum till here becomes greater than our memory, then what we need to do, we will make the memory is going to snatch the powers from sum till here. And also if the sum till here is dropping below the 0, then we will have sum till here to be 0, right? Because sum till here is so now, like, it has been destroyed completely. Therefore we are refreshing our warrior. I hope it is clear. And then we're gonna return our memory. I think I should call the memory as a king, but no, it's okay. So let's try to feed this and maximum subarray sum. Here we have only one number and -2, so the output will be -2, but in our case it is 0. And here if you say this one -3 -2, the output is -2. So basically, which is the maximum element present in this array in the cases of if it is all negative, right? So if in the case of if it is, let's say, all negative numbers, then what is the maximum element in this negative number? Of course it is -1, so the output has to be -1. That's why in place of 0 we're going to use a direct max element function. So basically it gives the maximum element present in the array. It is the stl method, arr. So here is what this is. It is gonna give the maximum element present in the array. Alright, so let's try to submit this. Alright, it's accepted. Now I hope it is clear what we are doing. The sum till here our warrior, and this we did because it was in case of all negative numbers, we only want the maximum element to be present there. Alright, so we'll meet you in the next video.